In this section, we will discuss about the Schmidt orthogonalization process. It is a process for constructing orthogonal bases. The basis is the important role of linear algebra. So, how to construct a basis vector from orthogonal basis vector and orthonormal basis vector from any basis of a vector space, that we will discuss about in this section. The orthogonal basis and orthonormal basis are the building blocks of the new topic inner product space and building block of linear algebra. We can say building block of linear algebra. So all of you can understand what is the important in the linear algebra and what is important in orthogonal basis in linear algebra. So here we can discuss about how to construct orthogonal basis from given any basis. So Schmidt orthogonalization is a process for constructing orthogonal basis for any basis. So first we can explain how to construct orthogonal basis on R2. So we have any basis u1, u2 in R2. So we need transformation of B into orthogonal basis. So step 1, choose V1 equal to U1. We denoted orthogonal basis in V's and given bases are U's. So we take choose V1 equal to U1. Step 2, we can construct V2. V2 equal to U2 minus U2 dot V1 by V1 dot V1 into V. So we have the space is R2. So in the basis of R2 have number of elements in basis of R2 have 2 elements, that we can say take that's why we can take B equal to U1 comma U2. Orthogonal basis, we need to construct orthogonal basis. So first element in orthogonal basis is V1, that we can set U1 itself. Next we can take V2, can be written as U2 minus U2 dot V1 by V1 dot V1 into V1. So these V1 and V2 be the orthogonal basis of R2. So in this way we can construct orthogonal basis of R2. Next one more explanation, how to find orthogonal basis in R3. We have a basis U1, U2, U3. u1, u2, u3 the basis of R3. So in this basis we need to construct orthogonal basis. So first step we can set v1 equal to u1 itself. Next step v2 equal to u2 minus u2 dot v1 by v1 dot v1 into v1. This is same as this itself. u2 minus u2 dot v1 by v1 dot v1. So v1 is u1, v2 is u2 minus u2 dot v1 by v1 dot v1 by v1. Next here v3, so R3. So here 3 elements in basis set. So we need to construct v3 also. v3 equal to u3 minus u3 dot v1 by v1 dot v1 minus u3 dot v2 by v2 dot v2 u3 dot v1 by v1 dot v1 minus u3 dot v2 by v2 dot v2 into v2. So we got v1, v2, v3 is the orthogonal basis of R3. Here I will discuss about one problem about Schmidt orthogonalization. Given that a basis is R2 minus 3, 2, comma minus 1, minus 1 is basis of R2. Transformed this basis into orthogonal basis. So first step we already say that v1 is same as u1 itself. So here u1 is this. So v1 is minus 3, 2 itself. Next to construct v2. v2 equal to u2 minus u2 dot v1 by v1 dot v1 into v1. This is the formula. So we need to find u2 dot v1. u2 dot v1. We can separately find u2 dot v1 and v1 dot v1. u2 dot v1 is minus 3, 2 dot minus 1, minus 1. So that is equal to minus 3 into minus 1, 3. 2 into minus 1, minus 2. 3 minus 2. That is equal to 1. u2 dot v1 is 1. And v1 dot v1 equal to minus 3, 2 dot minus 3, 2. That is equal to minus 3 into minus 3, 9. Plus 2 into 2, 4. That is equal to 13. So we get u dot v1 is 1 and v1 dot v1 is 30. So we can substitute in this formula. We get v2 equal to u2 minus u2 dot v1 by v1 dot v1 into v1. So u2 is minus 1 comma minus 1 minus u2 dot v1 is 1 and v1 dot v1 is 13. So 1 by 13 into v1. What is v1? Minus 3, 2. So that is equal to minus 1 minus 1 minus 3 by 13 comma 2 by 13. That is equal to minus 1 plus 3 by 13 minus 2 by 13. So that is equal to, we can add minus 1 plus 3 by 13, comma, minus 1 minus 2 by 13. So that is equal to, we can add minus 13 plus 3, minus 10 by 13, comma, minus 13 minus 2, minus 15 by 13. So V2 is this and V1 is U1 itself. This is the, that means V1 is minus 3 comma 2 comma minus 10 by 13 and minus 15 by 13. This is the orthogonal basis of R2 corresponding to this basis. Here given that in this problem to find orthonormal basis, not orthogonal basis. So here we find orthogonal basis. Next we need to construct this transformed into orthonormal basis. We have orthogonal basis. We can transform it into orthonormal basis. So how to transform orthonormal basis? So we have orthogonal basis. So and the orthonormal basis is pairwise orthogonal and each of the norms is 1. So here that means first of all the set is orthogonal. We get this set will be orthogonal. So first property satisfied. Next we need to do this norm will be 1. So how to So norm will be 1 means we can construct any vector construct to norm 1 vector. So V be the vector. So V by norm V is always W equal to V by norm V. That norm W is always 1. So here W1 is the orthonormal basis. So here V1 and V2. So V1 is constructed to orthonormal basis. So V1 by norm V1. So what is V1? V1 is minus 3 comma 2 divided by norm minus 3 comma 2. That is equal to minus 3 comma 2 divided by square root of minus 3 square plus 2 square. That is equal to minus 3 comma 2 divided by 9 plus 4, 13, root 13. So that is equal to minus 3 by root 13, comma 2 by root 13. So our W1 vector is minus 3 by root 13, comma 2 by root 13. Next vector is minus 10 by 13, comma minus 15 by 13. So W2 can be formed. So we can need to find a unit vector from this vector. So we have a minus 10 by 13 and minus 15 by 13 divided by norm minus 10 by 13 minus 15 by 13. That is equal to minus 10 by 13 comma 15 by 13 divided by square root of this square 100 by 169 plus 225 by 169, 15 square 225 by 169. So that is equal to minus 10 by 13 comma minus 15 by 13 divided by 325 divided by 169 square root of. So that is equal to minus 10 by 13 comma minus 15 by 13 divided by square root of 325 divided by square root of 169. So that is equal to minus 10 by 13 minus 15 by 13 divided by root 325 by 13. 13 will go to above. So we got 13 into minus 10 by 13 minus 15 by 13. So that is 13 divided by root 325. Root 325 can be 5. So we can write it as 13 into minus 10 by 13 comma minus 15 by 13 divided by 5 root 13. So that is equal to 13 we can take a inside. So minus 10. 13 into minus 10 by 13 minus 10 comma 13 into minus 15 by 13 minus 15 divided by 5 root 13. So that is equal to, we can divide minus 10 by 5 root 13 comma minus 15 by 5 root 13. So that is equal to minus 2 by root 13 comma minus 3 by root 13. 2 by root 13 comma minus 3 by root 13. So W2 will be minus 2 by root 13 minus 3 by root 13. So here we got W1, we already got 3 by 13, 3 by root 13 minus 3 by root 13 and 2 by root 13. Here we got W2 equal to minus 2 by root 13 comma minus 3 by root 13. So these W1, W2 be the orthonormal basis of given basis. So we got orthogonal basis. Next we got orthonormal basis of given basis. So we have any basis, we can construct orthogonal basis and orthonormal basis